Calculus, video 47, concavity and inflection points. Okay, so concavity, its definition is the rate of change of the derivative. The rate of change of the derivative. Or another way to think about that is the rate of change of the slope of the tangent line. Remember that we used the derivative. The derivative function gives us the slope of the tangent line at every point on the original curve. So if we say the rate of change of the derivative, that's the same thing as saying the rate of change of the slope of the tangent line. All right, let's see how we can apply that. I have a nice curve here. Let's call it F. And let's draw a series of tangent lines, right? So here's a tangent line here, and let's use a different color. And then tangent line here, and then tangent line here. There you go, that's probably enough. What we can see is the tangent line as we move along the curve from left to right is changing. It's got a pretty steep negative curve in the far left, a little bit less steep but still negative curve, and then again a little bit less steep but still negative curve. That slope of the tangent line is changing as we go along the curve. The rate at which it changes is called concavity. How is the slope of the tangent line changing as we go from left to right? Let's just talk a little bit more of that. What we're going to find out is this section, say from here to about right there, has a positive concavity. And you could recognize a positive concavity because it looks like a bowl that's open up, like you could put some cereal in that bowl. And we're going to find out that this section, say from this point here, this way, has negative concavity. And you could recognize that as an upside down bowl, right? Can't pour cereal into this bowl. It's upside down. That's negative concavity. And the point at which it changes concavity, this point here, is called an inflection point. An inflection point, the point at which the curve changes concavity. I have that written down a little bit lower, so you'll see that definition below. So positive concavity, negative concavity. Remembering that concavity is the rate of change of the derivative. Well, since f prime is the derivative, and concavity is the rate of change of the derivative, the rate of change of something is actually the derivative of that thing. We see that the concavity is given by f double prime of x. The rate of change of the first derivative is the second derivative. So concavity is given by f double prime. We'll need to find the second derivative to find concavity. Let's go back here, though. I want to keep making a few more points about this positive concavity versus negative concavity, because it does confuse students. So it's possible to have positive concavity while having a negative slope. In fact, all those blue tangent lines that I've drawn are negative, right? So even though it's a negative slope, it still has a positive concavity. What's happening here, if you have a negative slope, but that slope is becoming less negative. Less negative. That is an example of positive concavity. It's a negative slope where the slope is becoming less negative. Less negative means more positive. It's changing from a negative slope into a positive slope, even though it hasn't quite gotten to the positive portion yet. Okay. Positive concavity is also, let's put some more slopes on there. It's also positive slope that is becoming more positive. Right here, in this particular one, we have a positive slope, but it's just a little positive. And in the one just to the right of that, it is more positive. It's a increased slope there. So negative slope becoming less negative is considered positive concavity. Positive slope becoming more positive also positive concavity. It's becoming more positive. Okay, negative concavity. Now in negative concavity, we'll have slopes. Here I have a positive slope, and here I have another positive slope. But what you'll notice is, even though both slopes are positive, they're becoming less positive. So in negative concavity, you'll have positive slope, but becoming less positive. Positive slope becoming less positive is an example of negative concavity, or negative slope becoming more negative. Right? Negative slope becoming more negative is also an example of negative concavity. Right, that would also be negative concavity. Okay, very good. Let's go down and do some definitions. Concavity given by f double prime, that's going to be important. Concave up. The graph of the function f is concave up on an interval. Again, just like increasing and decreasing, we're only concave up and concave down on an interval. The graph of f is concave up on an interval if f prime is increasing. If the derivative, if the slope is getting more, bigger, going from negative to less negative, that would be as slope is increasing, or from positive to more positive. We find that this way, by the second derivative being positive. A positive second derivative concave up on an interval. Similarly, concave down. The graph of f is concave down on an interval if the f prime is decreasing, right? So that might be a negative slope getting more negative, or a positive slope getting less positive. Either way, that's concave down, and we find that by seeing the second derivative being negative on an interval. Right? So how do you find concavity? Well, you find the second derivative, and you find out when that derivative, the second derivative, is either equal to 0 or undefined. You create a number line like we did with the first derivative, and you find out when is it positive and when is it negative. So to find concavity, one, when is f double prime of x equal to 0? 2, when is f double prime of x undefined? Then you create this number line now with f double prime, putting those points right on the number line and looking for positives and negatives that would go in between. Concave up, concave down, concave up, that sort of a thing. Right? That's how we find concavity. Very similar to finding increasing, decreasing, relative extrema. And then the point at which the curve changes concavity is called an inflection point. An inflection point, the point at which the curve changes concavity, and you may see me refer to inflection points as IP, inflection point. if my little graph over here really was where it's positive, negative, positive, concave up, concave down, concave up, that would mean that both here and here would be inflection points, because those are points at which the curve changes concavity from concave up to concave down, or from concave down to concave up. All right, in the next video we will continue with the previous example that we had, the x squared times the square root of x plus 1, looking for inflection points and intervals of concave up and concave down.